Decreasing ice in the Arctic is now accompanied by a thinner blanket of snow, according to recently published research conducted by the University of Washington's Applied Physics Laboratory.
So what we found is that the snow over the Arctic Ocean, especially near the Alaskan coast, has decreased by almost 50% compared to the measurements that we have just 10, 20 years ago.
APL-UW's Ignatius Rigger says he's not too surprised.
We kind of expected it with declining ice extent, since most of the snow falls during the autumn, when the ice is retreated, it falls into the ocean.
If there's a delay in sea ice freeze-up, that means there's no platform for snow to accumulate on, which means that there's going to be a thinner cumulative snow cover. And that's what we see in areas such as Beaufort and Chukchi seas, where the ice isn't forming until much later. That's where we see the thinnest snow depths.
In 2012, Melinda Webster and Ignatius Rigger compared their snow measurements with data collected in recent years by air and with data gathered on the ground back in the 1950s by Arctic researchers from the then Soviet Union.
All of those measurements are from people who took measurements every 10 meters along a 100-meter snow line with a ruler during the Soviet Union era on drifting ice stations.
In 2012, a P-3B Orion aircraft from NASA's Ice Bridge project overflew an area near the western coast of Alaska, measuring snow depth. Webster and Rigger measured the same course on the ground.
Once they flew over our field camp, we got the positions of the plane over our area. We jumped on our snowmobiles, took out what's called a magneprobe.
It's essentially a ski pole with a moving magnetic basket. So when you stab it into the ground, the basket goes up and it can measure the distance between the tip of the ski pole and where the magnet has gone. And the instrument, which is outfitted into a backpack, records that distance or that snow thickness and the location. So we can take a lot of measurements very quickly.
Findings on the ground pretty much matched NASA's airborne measurements.
The correlation was pretty high. The bias or the difference between what we're measuring on the ground and the NASA P3 measurements were just a few centimeters.
UW researchers found the snowpack has dropped from 14 inches to 9 inches in the western Arctic and from 13 inches to 6 inches in the Beaufort and Chukchi seas.
Snow is one of the biggest unknowns as far as being able to predict what's going to happen to the sea ice. It's this critical interface between the ocean and the atmosphere and sea ice. Basically, since it insulates the ice and ocean from the atmosphere, the thicker the snow is, the less interaction there is. If the ice is thin and the air is cold, ice could grow like crazy. And so if we're going to model what's going to happen to Arctic sea ice and be able to predict it really well, we need to know how the snow is changing and how much snow is there.
It's definitely something that we'll monitor to understand better. And with the synthesis of all these airborne, in situ, and modeling data, we'll understand it better, but there's still a lot of work to be done.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.